All right, welcome back, class. This is Unit 7, Lesson 3, Expressions and Equations. So we will be able to examine equations and balance algebraic equations. But first, we will be starting with some review, and this is combining like terms. So like terms will be then when they both share a common variable, or in this case, 4 and 8 are constants. But I would like to combine my variable terms first. So 2x minus 5x. So we're looking for the difference. The difference between 2x and 5x is 3x, and the sign is negative because the negative 5 is bigger. And then we also will be combining our constants, 4 plus 8, and those are the same. They are the same sign, so we can add them together. So 4 plus 8 is 12. All right, and then again, negative 2y and a negative 8. We can rewrite this as, if we want, as 6 plus a negative 2y plus 4 plus 3 plus a negative 8. Now when we combine our like terms, we have negative 2y plus a negative 8y. So the signs are the same, so when we add them together, we keep the sign. So that would be negative 10y. Now we will, actually I'll use a different highlighter, combine our constants. So 6 plus 4 is 10 plus 3, and we can combine those now. 10 plus 3 is 13. So that'll be combining like terms. Some review. Now to start, we have an equation is a math statement that shows that one expression is equal to another expression. When the expression on one side of an equation equals the expression on the other side, we say the equation is balanced. So this equation on what looks like a balance here, we're going to check and see that these two expressions are equal. So let's do the left side first. Some order of operations. So we're going to do 3 times 4 times 2. So 3 times, when we multiply in the parentheses, 4 times 2 is 8. 3 times 8 is 24. Now let's check and see if it's equal on this side. Our final answer is 24. So we should get 24 on this side for it to be balanced. 26 minus 2, the difference will be 24. So those are equal. They're both equal to 24. So this expression here for the equation of both sides is equal. They are balanced. These expressions form an equation. There is only one value of n or c that will balance the equation. So we can only plug in one value for n to make n plus 25 equal 30. So this will be some mental math. What plus 25 is 30? And so if you said n equals 5, then you are right, because 5 plus 25 equals 30, which is true. 30 equals 30. So when n equals 5, this expression is balanced, or this equation here, the two expressions are equal. Let's check on this side. 52 equals 4c, so there's only one value for c that will balance them. So 4 times what is 52? So 4 times, well, let's think. 4 times 10 is 40. 4 times 3 is 12, so 13. Well, let's check. On the left, we have 52. On the right, we have 4 times, well, we're substituting 13 in for c. So 13, so 52 equals, I suppose we can do it over here, 12, 1, 52, yep. So now these equations are balanced. Here's another example. The algebraic expression 3x plus 1 equals the algebraic expression x plus 16. Notice that both expressions have a variable, 3x plus 1 and x plus 16, and they are equal to each other. These expressions form an equation. There is only one value of x that will balance the equation, and we will learn how to solve that later in this unit. But for right now, know that these two expressions are equal. They are balanced. We can show that expressions are equal by simplifying both sides of the equation. So by using our PEMDAS knowledge, we can show that this side equals this side. So first step of PEMDAS will be parentheses. So we'll want to simplify inside parentheses first. So 3, oops, I'm in highlighter mode. 3 times 6 minus 2 squared is inside the parentheses, so we must do that. 2 squared is the same as 2 times 2, which is 4. Oops, and I keep moving it. 4. So I'm going to simplify the left side first. 3 times 6 minus 4 is 2. 3 times 2 is 6. Okay, so now the right side should equal 6. So let's check. First step on this side will be to divide. So negative 4 plus 9 plus 1. We have a difference here, and we must go left to right. So negative 4 plus 9. The difference, it will be positive. The difference between 4 and 9 is 5 plus 1. 5 plus 1 is 6. So good, we found that these two expressions are equal to each other because we simplified both sides, and 6 equals 6. And that is true. Show that the expressions are equal. So again, we're going to do the same things. We're going to show by simplifying down that both expressions are equal. So let's do the left side. First, for order of operations in PEMDAS, we must do the parentheses. So 6 divided by 2 plus 3 times 4 minus 3 is 1. Then we can do 6 divided by 2 is 3 plus 3 times 1. Well, 1 times anything is itself, so 3 times 1 is 3. So we have, again, 6 when we added 3 plus 3. So the right side must equal 6 if the expressions are equal. Again, we must do parentheses first. So 5 times 3 minus 3 squared. Next, in order of operations, we must do exponents. So 3 times 3 is 9. That's what 3 squared means, 3 times 3. So we have 5 times 3 minus 9. Next, we will do 5 times 3, which is 15 minus 9. And 15 minus 9 is 6. Great. So again, when simplifying, we showed that this side equals 6 and this side equals 6. So both sides are equal, so the expressions are equal. In example 6, building an expression. Here we see an expression on one side of the equation. We want to write an equivalent expression on the other side. So first we need to simplify the left side. Again, we must do parentheses first. So 5 times 2 is 10 minus 20. Now we multiply. 7 times 10 is 70 minus 2. And that simplifies to 68. So for them to be, the expressions to be balanced or equal, the right side must also equal 68. So we can write an expression that equals 68. It can be anything. So your answers can vary up here. But I am going to put 60 plus 8, and let's check that. Let's check that down here. 60 plus 8. It should equal 68. When we add and combine our like terms, 68. So those expressions are equal because they both simplify to 68. Write an expression that makes the equation balanced. So the same steps. Simplify the left. Find what it equals. Now we must set the right side of the equation equal to that. So 6 times we must do in the parentheses first. 3 times 7 is 21 minus 10. 6 times 21 will be, let's see, 6, 12, so 126 minus 10. So when we subtract, we get 116. So we must set the right side equal to 116. So I can do 146 minus 30, and then we can check to make sure that equals 116. So 146 minus 30. So 146 minus 30 equals 6. Good, so it does equal 116. So we have verified that both expressions are equal because they both simplify to 116. It's important to remember that the expressions on either side of an equation do not have to look the same. So at the beginning, they do not look the same. However, to be balanced, they need to equal the same amount when simplified. So when we simplified, this side equals 116, and again, when we simplified the right side, it equals 116. So these expressions are equal. All right, so now you try, and then when you are finished, upload it and let me know if you have any questions. All right, thanks for watching.